Okay, so today's question is create binary tree from descriptions. So you are given a 2D integer array descriptions where description of I is equal to parent of I, child of I and is left of I. Indicates that the parent of I is the parent of the child is the binary tree of unique values. Okay, so all the nodes have the unique values. Furthermost, if is left is equal to 1, then child is the left child of the parent. If is left is equal to 0, then child is the right child of the parent. So we have to construct the binary tree described by the description and return its root. And the test cases will be generated such that the binary tree is valid. Okay. So this is the description given to us. So what we will be doing, we will be creating each nodes, okay, and we will create a set of children which will contain the unique childrens. And after creating this tree, how we will know which is the root? We will go through the children, and if a particular node is not in the children, that means it's the root of that particular binary tree, and we will return that. So let's try to code this. So first we will create a dictionary for the nodes, okay, and then we will create a set to store the unique children is equal to this. Now we will simply go through the description given to us. So for parent comma, second one is the child and the third is left. In descriptions, okay, for parent child is left in description, we will check if that this particular node is already in the nodes or not. If it is already, then we don't need to create again a node for this particular value. So check if parent parent not in nodes, if parent not in nodes, then simply create the key value here. So nodes of parent is equal to create a node, so tree node, and pass the parent to it, the value. Parent is nothing but the value. Again, now similarly check for the children. So if child not in nodes, so nodes of child, create a node here, tree node. This tree node is nothing but this is actually defined above, as you can see here in the comments. So tree node of child. Okay, now we have created both the nodes. See, first thing was this parent node, this child node. So we have created the nodes by the values given, and now we will check this is left. If is left is equal to 1 or is left is equal to 0. So if is left is equal to 1, that means this child is the left node of this parent. So nodes of parent dot left is equal to nodes of child. Else if it's 0, then it is the right node. So nodes of parent dot right is equal to nodes child. Done. Now we have created a particular small tree for this particular parent child. Okay, now we will simply what do, we will add this child to this children's here, so that we can store the unique children. So uh, children dot add, what we will add, child. Okay, now what is left? Now we will again go through the descriptions and we will check, okay, if the following parent is in the child or not. If suppose a particular parent is not in the children, that means it is the topmost, that means it is the root. So we will simply return that particular node. So go for parent, only we need the parent, you can leave another ones in descriptions. Okay, if the parent is not in, if parent is not in children, so what we have to do, we have found the root, simply return the node. So return nodes. What this node is containing, this is containing the value map with its tree. So return nodes of, what will be nodes of that parent. And yeah, this should work. Let's try to run and check. Invalid syntax where a parent is not okay. It's not is. I must say parent, a parent not in children. Let's try to run and check again. Yeah, so test cases has passed. Let's try to submit and check. Okay, so our code has passed successfully. Thank you for watching.